Welcome back. Today we will talk about consistent hashing. Consistent hashing, and today it will be a quick video. We'll talk about consistent hashing, and in the next video I will make more longer video to talk in depth about consistent hashing. So I expect this video will be like 5 minutes or something like that, and maybe the next video it will be like 40 minutes, something like that. It will be quite long one. So let's talk about consistent hashing. Consistent hashing is a technique used in distributed system to efficiently distribute data across multiple nodes or servers while minimizing the need for data reassignment. And this is the important thing. When nodes are added or removed from the system, it's commonly used in distributed caching system, load balancers, and distributed database. So let's just try to make an example to see how it works and what the benefits from it. So let's just think that we have this hash ring, and if you don't know what is a hash ring, that you can think about the hash ring as like a data structure, like circle data structure. We store the nodes on them like the servers. So let's assume that we have 4 servers, okay, like that, each one here, okay, and we have 4 let's see, we have 4 can I change the color here? Yeah, we have 4 keys, okay, one here and one here and one here and one here. And the way that we try to store these keys, because as we said before, that it's a way the consistent hashing is a technique is used in the distributed system and database, and it's a way that how we will store these keys for each database or for each server. So we have this key, or we have these data, and we want to store them. So the thing that we go like a clockwise, and we try to store each key to each server, and we do that with each one here like that, and we go like that and like that. We meant the pen was, and by this way we make sure that we store each data in each server. And the good thing about consistent hashing is that when we lose one server, so let's say that this server was full, all the other keys will not be affected by that. The only key will be affected, it's only this data or this key. So this key will be saved. Sorry. This key will be saved in the next server, and by this way we'll make sure that we minimize the reassignment of the data when nodes are added or removed. So basically, if we have node been removed, we'll do that. If we have not been added, like this one, we add one here, the only one will be affected is this data only. It will be saved here, and instead of being saved here. So this is the way that we minimize the data reassignment when nodes are added. How this work? Basically, we hashing data and nodes like in consistent hashing. Data items and nodes, as you can see here, are hashed using consistent hashing function. This hash function maps each data item and each nodes to point on a circular hash space, often represented as a ring, as you can see here. We have the data replacement. The second thing, data items are placed on the hash ring, as you can see, like for each data item, which is represented by the yellow, are represented on the hash ring by their keys. The resulting hash value determine their position on the hash ring. Similarly, each node is hashed as well to determine its position on the ring, as you can see also here. We have the routing data, like where do we store this each key to which server. So when a request is made to access a data item, the same consistent hashing function is applied to the item's key to determine its position on the ring. The request is then routed to the nearest nodes in a clockwise, as I said before. So it will be it will be sent in a clockwise direction from the data item's position on the ring. This node become responsible for serving request data item. We have I talked before about the adding or removing nodes. So when a node is added or removed from the system, only the fraction of the data items needed to be remapped to new nodes. This achieved by selecting the data items whose position on the ring are closest to the departing or arriving node and reassigning them. The majority of data items remain unchanged, providing stability and reliability and minimizing data migration. So it looks good, but why we need the consistent hashing? So first we need the consistent hashing in reduce data migration by assigning data items to nodes based on their position on the hash ring. Consistent hashing minimizes data migration when nodes are added or removed. This particularly important in large-scale distributed system with massive database. It's great also for scalability. So basically, consistent hashing provides stability and the scalability to the data distribution, ensure that most data items remain unchanged even when nodes join or leave the system. And this stability is valuable in systems that require predictable data placement. It's good and high availability. The good thing is because as you can see that we could replicate the data across multiple nodes to make sure that we have that our system will be available all the time. So consistent hashing enhances systems availability by allowing for easy failover in case of a node becomes unavailable. Requests for data items previously served by the failed node can be routed to the nearest available nodes without affecting the majority of the data items. In summary, consistent hashing is a valuable technique for efficient data distribution and load balancing in distributed system. It enables dynamic scaling, high availability, and efficient caching distribution while minimizing the need for extensive data reassignment when nodes are changed. This makes it a fundamental tool in building a robust and scalable distributed system. So that's it. That was a quick overview for consistent hashing, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you never miss a video, and see you in future problems.